A very good afternoon and a warm welcome to one and all present here. This is Dr. Maheshwari, Head Department of Mathematics, Kumaraguru College of Technology. On behalf of Kumaraguru Institutions, Department of Mathematics is happy in inviting you all for the 5-day short-term training program in modern mathematical tools for calculus and analytics. Today being the second day, we are going to learn on the SageMath and its applications. The development of SageMath is extensively used as a free open source mathematics software system licensed under the GPL. It builds on top of many existing open source packages, NumPy, SciPy, Matplot, SymPy, Maxima, Gap, Flint, R, and etc., which has been accessed and then combined through a common Python-based language or directly via interfaces or wrappers. SageMath is one of the well-designed approaches to blur the boundaries among being a user, developer, and a contributor in the open source software ecosystem. Now, this SageMath session with its plots will be well explained by our dear speaker, Dr. Dhanasekar. Dr. S. Dhanasekar is a renowned person from Vellore Institute of Technology, Chennai, with more than 15 years of teaching and research experience. Apart from teaching, he holds a lot of responsibility like a program officer from National Service Scheme at SRM University, an active coordinator at VIT Film Society, VIT Chennai. His areas of research are fuzzy optimization, network problems, optimization, and wavelet theory. He has also been an invited speaker to various colleges in Chennai and in other states. He is skilled in R, MATLAB, Mathematica, LaTeX, etc. He has published numerous research papers in national and international journals. To his credit, he has organized a lot of workshops and hands-on training sessions that has been sponsored by UGC and CSIR. He is also guiding research scholars at VIT Chennai. Even before handing the session over to the speaker, I would request the participants, if you have any questions during the presentation, please post them into the Q&A tab in your Zoom control panel. It will be answered at the end of the session. The feedback and the assessment link will be posted in the chat box. All the participants who fill the feedback and the assessments for all these days will be given the e-certificates. Now, I request you to take over the session, sir, and continue with your new SageMath. Over to you, sir.
Thank you very much, Maheshwari ma'am, for your wonderful introduction. And I'm S. Dhanasekar from VIT Chennai campus. I'm working as an assistant professor in VIT Chennai campus from 2012. Previously, I worked in SRM, right? So I will on my video for a few seconds, then I will off it, right? And welcome to this wonderful STTP. Okay, they organized in a well mannered, right? Because yesterday, Dr. Vijay Lakshmi from Central University Tiruvallur talked about optimization and optimization tools in MATLAB. And today and tomorrow, myself and Dr. Manivanan will actually introduce SageMath and what are all the things you can do it in SageMath. That's what myself and Dr. Manivanan are going to do. And our another colleague, Dr. Parthiban, is going to take GeoGebra on Thursday. Right? Friday, you have another software called Tableau, right? So it's a very good initiative by this Department of Mathematics, Kumaraguru Institution. I appreciate their effort because they actually designed this workshop very well so that you can learn about some more software, some 3 or 4 softwares you are going to learn so that you can apply it in your teaching field or whatever research field, whatever you are going to do it, right? So I appreciate Dr. Maheshwari ma'am and our team for conducting this or for organizing this kind of thing. Thank you. And also I thank Dr. Manivanan for introducing me to Dr. Maheshwari and this department so that I had an opportunity to give a lecture for this SageMath, right? And we have 2 set of people are with me. One is Dr. Manivanan. He is there in the panelists, and Dr. Parthiban, who is there in the panelists, right? And Already Dr. Maheshwari ma'am told about how we are going to do it. Today we are going to have an hands-on session. So whatever I'm going to do in the SageMath, right, code, the code will be posted to you in the chat box by any one of us, right? Yeah, that is Manivannan or Dr. Parthiban, so that you can copy the codes and paste it in the wherever we are going to do, right, and have the result then and there instantly, so that you will have a working environment, hands-on session. So that's how we designed this thing, right? That's a one thing. And second thing, if you have any question and answers or any queries, you can post it in the QA, so that our panelists, Dr. Manivannan and Dr. Parthiban, will reply it then and there. Otherwise, we will have it in the last, right? The query, we will have it in the last thing, right? So this is what the plan is all about, right? I hope I can give some insight to your knowledge about SageMath. You got it? So let's get into the thing. Now I'm going to share my screen, right? So I'm going to share this my Google screen, right? So that we will go for it now. Already Maheshwari ma'am told about what is SageMath and all that, why we need SageMath and all that, right? But again, I'm going to what you call insist upon why we need SageMath. The first and foremost thing is, right, it's an open source software that is very important, because we don't need to pay the amount and get the thing, because all other softwares, MATLAB, Maple, Mathematica, right, those things you have to pay money, right, and you have to get a licensed version. Then only you can work on it, right? Even though they are very sophisticated thing, MATLAB is a very sophisticated thing, right? But you have to pay huge amount of money to get it, to get a license from that. So that's a one point of view. It's a great advantage to have a SageMath. The second advantage is SageMath is designed only for mathematics. That's a very important thing we have to remember. SageMath is designed only for basically mathematics. For mathematicians, it's actually designed. Okay, that's a second advantage of why we need to use SageMath. And the third thing is SageMath is getting the help of more or less more number of open source softwares in his environment, so that it will give you it will be a good environment to work on more kind of open source softwares, right? These are all the three main disadvantages. And fourth main advantages, the fourth main advantage is documentation parts. It's clearly documented. Since it's an open source software, it is clearly documented. You can get any kind of documentation from this, right? Now, first of all, right, I will tell you how to work on it, right? Now, first, I'm going to actually, I'm going to open the SageMath thing, right? So this is the SageMath, www.sagemath.org, right? SageMath open source mathematical software system, right? Now, if I go and click it, now see that I'm getting this kind of thing, Sage. So it's an separate website for Sage, right? This page will open here. Now in this thing, see that SageMath is a free open source mathematical software system, right? And it builds on top of many existing open source software. See that NumPy, SciPy, Matplotlib, SymPy, Maxima, GAP, Flint, R, and many more. So it builds upon all these. So we can get help of all these open source softwares. What is NumPy? NumPy is nothing but numerical Python. Python, it's a numerical computation in Python. SciPy, it is scientific tool of Python, right? Matplotlib. Matplotlib is another Python thing which is helpful for us to plot, right? SymPy, Maxima. Maxima is another mathematical open source software, right? Okay, all these things. R, you already know what is R. R is an open source software for statistics. So your SageMath is built upon all these open source software. What is that meaning? It can take a help of these things and you can work it on SageMath. So it has a very powerful thing, right? It's not like that it's a single software. So it can get help from all these things. Are you able to understand, right? That's a more advantage of SageMath. So if you get this kind of page, see that, right? Okay, you will have a thing like this. see that here download 9.1 version. If I go and click it in the new window, right, see that download binaries, right? You have a Sage download, right? For Windows, you have a Sage download, right? For Linux, you have a Sage download. For Apple and Mac OS, you have a Sage download. So you can download it and you can store it in your system so that you can work on it. So what you have to do is choose the nearest Indian thing. For example, you can choose Australia, right? Nearest server. If you go on click the nearest server, for example, if I go on to click USA server, right? Open new software, right? See that here download thing is there. I can download it and install it for Microsoft Windows, for Linux, for Apple. This is one way of working out the Sage, right? So if you go on to do that download part, so it will take about, for example, right, I think it will be up to 5 GB or something. It will take from you to install it. For installation, another 1 GB will be there. Almost it will come under 5 GB, right? So you can take this, download it in your system, and you can install it. That is one way of doing it. Are you able to understand? You can download it, but don't download now. It will take time, right? If you are free in the evening, download it and install it in your system so that you can work on it. Are you able to understand? This is one way of working out your Sage thing. Are you able to understand? SageMath. Right now, let's come to the one minute. One minute. I came out of sharing. Now I will share again, right? It's already shared. Is that my window is visible? Money?
Sir, you only visible, sir.
Okay.
1 second, sir. I have to, I think, pin it.
Now is it my window is visible?
Now only. Yeah,
okay,
now visible, sir. Now is.
Thank you. Now
sir,
this is.
And one more important point. So that says, dear participants, please don't put the good afternoon and welcome messages, because we people going to put the comments codes in your chat boxes so that you can copy and paste after the information you got from Dhanasekar sir. So don't fill the chat box, because some people may go to lose the codes and all. So please try to avoid the greeting messages here. Thank you.
Okay.
And you may give if you have any query, you may post it, and then we will address you. Thank you, sir. You may continue.
Thank you, Mani. So next we are going to work it. How to work it without downloading the SageMath. So we have many platforms are there, right? Okay. So we are going to see only 2 platforms. How to work SageMath, right, without downloading it. The one is, right, this one, which is called SageMath Cell. SageMath Cell. I'm going to go for SageMath Cell server. If I go and click it SageMath Cell server, I will get a window like this, right? Now, whatever thing I'm going to post it. For example, if I put plot of, right, sin x. It's a very simple code in Sage. Now see that the language. In the part of language, you have plenty of softwares are there. GAP, GAP, GP, HTML, right? Octave. Octave is another open source software. Similarly, it's like MATLAB, Python, R, Singular, any kind of what do you call codes of these languages, you can work it here. Now, if I put evaluate, now it's evaluating, right? Okay, and see that it's giving the answer for me, right? Now, right, if I want to give some range here, example, I can give 0, 2 star pi. If I give it here, right, and run it again, evaluate. Now again it's evaluate and it's giving the sin x curve from 0 to 2 pi. Are you able to understand? Right? This is one way of working it in the cloud. Right? Whatever Sage code is there, you can put it here, click evaluate, you will get the evaluate part. The only main disadvantage in SageMath Cell is you can't store your program. If I want another one, what I should do is I have to erase this and copy and paste another code. Then I have to evaluate it. Like that only I have to do. For example, if I want to go for anything, a equal to 3, a equal to 3. Now, right, a equal to 3. So it won't display. If I call a only, it will display. Now, if I evaluate, right, see that. If I call only, it will display. So whatever the code, I'm going to put it here and evaluate. If I got the output, if I want to go to the next one, I have to erase the previous code and do it. So I cannot store the code here in SageMath cell server, but I can work all the codes in Sage codes here without what you call without downloading the things. Are you able to understand? Right? Okay. Right. Now, this is one thing. Now, 1 minute. Now, this is one way of working out your SageMath in SageMath cell. Now, the another way of working it out is SageMath Cloud. That is GoCal. Now, wait for some time. We will come to the GoCal thing, right? Now, before that, we have plenty of things here, right? We have a call library. We have a call doc. Yes.
Dhanasekar sir, 1 minute. Participants, I think they are putting the message like they cannot copy from the chat box. So the host, maybe Anita ma'am or Mageshwari ma'am, are you there?
Yeah, we are there, sir. Even we saw that.
Yes, ma'am. You just try to give the options to copy from the chat box for to the participants, ma'am. Maybe the settings you done it.
Oh.
You just do that, ma'am. Within the time, SAR will give the how we are going to do that on the GoCal canal.
Okay, I'll
just
check
try,
out.
ma'am. Parallel,
Yeah,
you just do it.
Yeah.
Thank you, sir. And Dhanasekar sir, you can go, sir.
Thank you, ma'am. Thank you. Now, before getting into the GoCal thing, right? Now go to the documentation part. If I go and click the documentation part, right? Now, if you see that 1 minute. Oh, right? Why it's coming like that? Now, if I click it here, it's a documentation part. See the documentation part. PDF is given. You got a plenty of what do you call topics. See that algebras, arith group, asymptotic, calculus, categories, coding, correction, combinatorial, constant, C Python, right? Graphs, all are there. All the things, right? They have a documentation of each and everything for Sage. For example, if I go on to click graphs, right? See that this documentation part is coming Sage 9.1 reference manual graph theory. It releases for 9.1, right? Now, if you go and see the date, it is actually updated on May 21st, 2020. Recently only they actually updated. If you go on to do that, all the Sage code for graphs will be there, most of the codes, right? See that it will be like the book will be, the documentation part will be, a graph code will be the Sage code, and example will be given to you how to do it, right? Simply, if you want to know what, right, study it, copy the code, paste it in the SageMath cell or in the GoCal, you will get the result. Are you able to understand? This is called SageMath documentation. This is actually, we done it for, right, this thing, right? That is, we actually click the graphs. Now I can click anything. For example, rings, right? For example, TensorFlow modules, structure, stats for statistics, for sets, right? For numerical thing, for matrices. Are you able to understand? There exists many kind. If you see that, all are maths related thing. So SageMath is only for maths, right? It's especially done it for math. They actually designed for math. For pure algebra also you can have. That is abstract algebra, right? If you click algebras, you will get plenty of things. Click plot 3D. You will get all the documentation part of plot 3D, right? Plot 2D is also there. For see that game theory is there. Finite rings is there. Finance is there. Dynamics is there. Discrete geometry is there, right? All the things which are all very basic. We can see that it's all abstract algebras, abstract thing that are all done done. You can do it by using the SageMath code. This is for documentation part, right? Now we have a thing called, right, Another thing is there, library. If I go on, click the library, see that SageMath library. You have many books are there in the library. If I click books, right, see that all the books which are written on Sage, it is actually displayed here. You can go on to click anyone and get the book for it. For it, right? Many books are there. Concrete algebra, combinatorial reciprocity theorems, right? Calculus, mathematics for Sage, right? Yeah, linear algebra and differential geometry with Sage. Sage for undergraduate, Gregory B. Bird, right? If I go and click it, right, it's coming like this, right? Not found. It will be there. You just check it up, right? Okay. Right. Most of the books, it will be there, right? It won't be not found. There's linear algebra for Sage for undergraduate. I already downloaded, right? Many kinds of books are there. You go and click it so that you will get it. So it has a many library things. Library books are there. Another one, videos is also there. New article, SageMath in news, right? Publication using SageMath, marketing, right? Standard documentation will be there. Or able to understand, videos is also there, teaching materials, interactive worksheet for calculus 1 and 2, teaching with SageMath. If you want to introduce SageMath in your thing, you can introduce it. Like that, you can have many things, SageMath library, right? So if I go and click the library again, right? So I have many things, publication, testimonials, all the things are there. Are you able to understand, right? Okay. So that's why we can go for SageMath because plenty of resources are there in the thing. Are you able to understand? Right? Now let's come to the GoCal part. Now, how will you do the GoCal part? If I go and click at GoCal, right? So GoCal is a nothing but it's a front end, right? You can work any kind of things here. I already opened it, therefore it shows like this, right? For example, right? If I use GoCal newly, GoCal. Now, if I go and click it, now it's opening the way it's already opened in my computer. Otherwise, what it will have, for example, if I came out of this sign out, yes, sign out, I'm coming out of it. Now see that this will be the window you will get it when you click the GoCal. Now GoCal it is a nothing but it's a collaborative calculation and data science. You can work on many things. See that Octave, Python, R statistics, teaching, LaTeX also you can do it. Jupyter Notebook is there, right? It's a front end for working on most of the open source softwares. You can work on it, right? Now if I want to get sign in, put sign in. If you are not already sign in, right? It will ask you to sign up with Google. See that. It will ask you to sign up with Google. Create an account, connect with Facebook or Google or Twitter account. So you can do it. Are you able to understand? So you can sign up here so that if you click Google, right, automatically everything will be there and you will be sign up. See, I'm sign up using my Gmail, right? So I'm signing it. I'm going to put it sign in. So it will get into it. Are you able to understand?
Sir,
Yes.
sir.
Yes.
Give 2 to 3 minutes time, sir, so that they can
Okay.
open an account, sir. Wait for 2 minutes.
Okay, okay. All of you, please open it so that it will be useful for you for this 2 days, today and tomorrow.
Participants, I think the organizers may be rectifying the chat box copying things. Okay. Meantime, you can go to the website gocalc.com and you can open an account using your like the steps are told, using GitHub, Facebook account, Twitter account, or any Facebook account, Gmail, anything. You can use it on user ID and you put your password and you can come to this page, GoCalc. Please open an account. From that we can do it. Maheshwari ma'am, please do rectify
Sir,
it, ma'am.
actually they have the access on the chat box, sir. I just got only one message. So otherwise it is, they are in a position to copy the messages from the chat box.
Even I cannot copy, ma'am. Even for
Oh,
me
okay.
also it is
I've just asked there, sir. Just hold on, sir. I'll just.
Okay, ma'am. Do
Yeah.
it because we will paste the code so
Okay.
that people may copy and paste.
Okay.
Dhanasekar, sir, you may continue, sir.
Yeah. Is there any problem in opening the account?
Not opening account, sir. From the chat box, people cannot copy, sir.
Yes, that's okay.
No, I'll just check it out, sir. Just give me some time.
Okay. Participants, if you are troubling with open an account, you may put in the query in your chat box. Totatri Venugopal sir, from your comment only we are seeking this one. So no need to ask again and again. If it is not copy means you just inform us. Not get the link, Lata SK ma'am. Which link ma'am? GoCal.com. Directly type in your Google browser or Microsoft, any browser you may type.
COCALC ma'am.
COCALC. .com. GoCalc.
You type it GoCal itself, it will come in Google. Parthiban sir, are you there?
Yes, sir.
Is there any way to activate the thing which they done to post our message in the chat box so that they can copy and paste it?
If I am host, maybe I can check something, sir.
Okay.
But I don't know what's the.
Parthiban sir, I think you are the co-host. Oh.
No, sir.
Oh no. Okay, I think they are.
So all of you open the account. Do you find any difficulty in opening the account in GoCal?
Actually, for the first time, we are facing this kind of problem.
Yes, sir. Parthiban sir. Usually we can copy from directly from that. It's given me the select all option. Even I am the host. For me also, it's give me.
No, is there any settings there?
Yeah. That's what they made that settings like that to not to disturb others, right?
Go to settings and try to change the settings.
I tried Parthiban, but.
Mani, you check it up in the QA whether you put it in the QA whether they can copy it from the Q&A.
Q&A I will try, sir.
That's what Arun Prakash actually telling.
Sir, now they are able to access, sir, no issues. They are giving the messages.
Okay.
We are able to access, ma'am. So
okay.
No issues.
Mani, you check it up so that we can start. Thank you, ma'am.
Yeah, you can.
Sorry.
We
should
no
have
problem.
Ma'am, Mageshwari, ma'am, one point, ma'am. You just try to copy from your chat box, ma'am.
Yeah, I am able to copy, sir.
Okay, then Parthiban sir, you just try.
No. Manivannan, it says that only it is selecting all.
Yes, for me also it is select all, ma'am, only, not particular part, ma'am.
Oh.
Yeah, Arun Prakash are also telling that still we can't.
Okay, I'll just find out.
Ma'am, you just make a co-host to Parthiban sir. Sir also may be trying in the another way.
Parthiban sir's name is not visible.
Ma'am, I think he is in Dhanasekar.
Why Parthiban, you are in the Dhanasekar name?
Is it so?
Maybe he renamed.
No, it is
his mail ID only. He renamed it.
How it has been changed? Okay.
He's already promoted as panelist, sir.
Okay.
Panelist, ma'am, but not co-host, ma'am.
Oh. Yeah, now I have promoted, sir. Please check.
Thank you, ma'am. Thank you. I will try.
Mani, you just put it in the queue, Mani, whether they can copy it from the queue.
QA also I can, sir. It's open, answer, dismissed, sir.
Oh, only that thing are there. Okay.
And then from that settings also I'm trying, sir, in another way.
Dhanshay sir, you continue, sir. In the meantime, we will rectify these things.
Okay. So shall we start, right? Now,
Yes,
these
sir.
are all the main advantages of SageMath, why we are using it. Now, actually today what I am going to do is, actually I'm going to give an insight into the matrices part and how to plot the functions in the SageMath, because that two are very important, because when we are teaching the students, right, the mathematics thing is it's a little bit abstract, right? Student doesn't know what is happening in the function, right? Whenever we are differentiating, whenever we are finding maximum minima, whenever we are telling that level curves are there, contours are there, vector field is there, no, you can't able to visualize the things. That's a very disadvantage of the thing. That's why students are not that much what you call interested in mathematics, right? That's what all over the world, right? They are facing the problem. So to overcome that, actually these softwares may help us to do those things, right? To visualize a thing and to do the many complicated kind of thing. For example, if I want to find out inverse of a 40 by 40 matrix, then it will be difficult for me to do it manually. And if I go for C program, right, I have to write a program, right? Line by line, I have to write a program, C or Java. But these softwares help us because it's already built-in function, right? So I can use only one command to get all those things, so that I actually my time is actually saved. So I can save my time to work on my conceptual things. Are you able to understand? That's what these softwares are very helpful. We are not telling that you have to replace everything by this software. Please remember that these software will help us to do mathematics little more efficiently. That's what we are suggesting. All the panelists or all the things, right? We have to think this of softwares like that only, right? Okay. So that's what the thing. Now I'm going to. I think this window is visible for you, right? Okay. This is how. Now how you can get it into this, like this is, right? Let's go to the project, right? Now if I want to create a new project, I will put a create a new project, and there a project title will be here. Project title will be here. You can give a project title here and put a create a project. For example, this is STTP, okay, Kumaraguru College. So I'm going to put it as Kumar and create a project here. See that a project will be created. Project will be created. See that STTP Kuma it is there and it is loading actually. So no files are found out. So what I should do is I have to go to the new, click new, put Sage worksheet. Sage worksheet. Now again, you put any kind of file name. It actually created a folder. Now put any kind of name, file name. Otherwise, it will take it as a file name as 11/8/2020, right? And its time is 2:35, 14:35. Are you able to understand? Defaultly, it will take it as this as your file name. If you want to give it a file name, for example, if I want to give this file name as something else, I have to erase this and put plotting. For example, I'm going to put only plot, right? Create. Now see that the plot Sage worksheet is here. Now if I click this, I will get a window like this. Here I can type anything. For example, if I type plot, PLOT of plot of sine x, sine of x, here, right, sine of x, and run button. This run button is for running, right? So this green, it says that it is working on it. For the first time, it will take time because it has to connect with the server. So it is still working on it, and it will give you the result here. Okay. It will give you the result here. So it's still working on it. Are you able to understand? So this is how you can work. See that it gives you the plot. Are you able to understand? So if I want to do the next plot, right? If I click it, now here again, if I type a equal to 3, right? A equal to 3 colon a. Colon a is nothing but it is actually dividing the line. Now again, if I select it and run it, See that I'm getting the answer here. So the next code, I can type it here and run it. This is the way you can do it, right? And it will be in your account all the time. Whenever you open it, it will all these programs will be there in your account. Are you able to understand how to create a new worksheet, right? Okay. All of you. Now today we are going to Sadiq Ali raised hand. I don't know what is the problem. Is it the problem rectified?
No, sir.
No. Okay, so what we will do, we will just show them the codes.
Wait, sir. 2 minutes. We will discuss. Sir. Parthiban, are you there?
How to get this window? Chintamani Srinivas. What window?
Maybe the GoCal window.
Manivanan,
Yes.
post something in the chat box.
1 second.
The project window, right? You go to the GoCal. It says that no, there is no thing. Go to the new, create project.
Manivanan, I can able to copy now.
You can able to copy now, right?
And check with other participants, Parthiban. I cannot.
Actually, in the
Participants,
mobile phones, it cannot, but in the system, it's working.
no, for me also it's not working.
I am in system only, Parthiban.
It says select all only.
Yes.
I can able to copy.
No, it's select all only. It's coming.
Okay, whoever can copy, you can copy it, right? Seema Patel says that not working, right? What we can do is, otherwise
Anyway,
we will,
sir, this has been uploaded in YouTube as well as it has been recorded. So if at all they wanted to do the hands-on session, I think they can refer to this and they can do that, sir.
okay, ma'am. Okay.
And, so
Thank you,
that's
ma'am.
not an issue. Yeah.
Thank you,
that is
ma'am.
what-
Thank you.
Yeah.
Otherwise, can you send this Word file to them?
Yeah, we can do that, sir. If you share this, we will share it with all the participants. That is yet another option.
Okay. Manivanan, can you just send it to Mageshwari ma'am so that she will send this text file to all?
Yes, ma'am. Yes, sir. I will share it, sir.
Yeah,
The
that's
whole
a good
file.
option.
Right.
Yes, sir. So you can just continue, sir. Yes, sir.
Okay, ma'am. Okay. Right, participants, your text file will reach you, right? So that you can take it from that and you can copy it and paste it. Right? Now, I hope you don't have any problem in opening this GoCal. By assuming that I'm just starting my thing, right? If you have any problem, you post it in the chat box so that Dr. Parthivan and Dr. Manivanan will resolve those issues. Got it?
And I think the problem is most of them are using the mobile, sir. It is working through the system. Yeah, most of them are using the mobiles. Yeah.
Okay, ma'am. Then no problem.
Mageshwari ma'am, I forwarded the mail to you.
Yeah, thank you, sir. Okay, sir.
Okay, fine.
Manivanan, even though it is forwarded, you just paste it. Post
Yes,
it
sir.
in the,
I will parallelly do it, sir.
so that whoever can do, they can do. Right? Thank you, Manivanan. Right? Okay. We will start the session, right? I already told that this session is going to divided into 2 parts, right? 3 parts actually. First part is introduction. It's over. Now you opened a GoCal account. If you can't able to open it till now, right? Go to the SageMath cell and work it, right? So that you can have a hands-on session. Otherwise, right? You can have it in the evening because it's YouTube live is there, right? And you can have it thing, right? Are you able to understand? Okay, so now we are going for this first one is line. We are going for this command called line. So this command line, what it will do is it will actually connect the points, right? 0, 0, 1, 1, and 2, 2. It will connect it as a straight lines, right? It will connect it as a straight line, right? If I'm going to run this, if I select this and run this, right? And run this. See that I'm getting a line. So it actually connects 0, 0, 1, 1, and 2, 2. So this is the line command, we can have it. Line command, we can have it, right? Okay. Now, next we go for plot. Next we go for plot. I already told that we have a plot command, plot 2-dimension figure. P equal to plot of sin x. P equal to plot of sin x. Plot of sin x. First, I'm going to run it. P equal to plot of sin x. Right. Now, what it is actually doing is it shows P. Right. My P is different. 1 minute it will be here. See that P equal to plot sin x. It will be there. Plot sin x is here. Plot sin x. It is here, right? What I will do is I will make all these things, right? I will make it as a command and now if I want to add the what do you call the range? The range is I'm giving -2 pi to +2 pi, and I'm going to tell that it has a thickness. I'm going to tell it has a thickness of 2.0. The line has a thickness of 2.0, and I can give the color as like this. This is one way of giving the color for the curve. RGB color, red, green, blue, where red is 0.8, green is 0.4, blue is 0.2. So which is predominant? Red is predominant, right? We will come to this line style later. Right? Not now. Okay. 1 minute. I will take this out. I'm going to take this line style out. Right? And this legend label will give you the what do you call sin x, the topic of the graph, what you are going, the heading of the graph, sin x, and the p1.axis underscore labels. So it will label the axis as x and f of x. Now we are going to show p1. That is, this plot will be shown here. Now I am going to make it this as command. The command is, if you put it this asterisk symbol, right? This symbol as hash. What it will do is it won't execute that line, right? It will take it as a command. Now if I'm going to run this, see that I got a sin x curve from -2 pi to +2 pi with the thickness 2. If the red is predominant, therefore it is red. The red is predominant, therefore it is red. Are you able to understand? Now, if I change the color, for example, if I give this is 0.1 and this is 0.8 and this is 0.2. Now again, if I run it, see that green is predominant here, therefore green color of curve because its percentage is higher. Now see that the legend label is sin x here, y-axis is labeled as f of x, x-axis is labeled as x. Are you able to understand, right? This is how to get the plot. These are all extra things. Now in the same thing, if I give line style, equal to, so in single quotes, right, double hyphen, line style equal to, single quotes, I'm going to put double hyphen here, right, another hyphen here. Okay, single quotes, put comma here. So this is legend label sin x. Now if I run at this part, see that I'm getting a curve with a dashed line. This line style will make the curves, the curves orientation or not orientation, the style of the curve, whether it will be a solid curve, whether it will be a dashed line, that all the thing I can give it by using line style. And this is the RGB color, red, green, blue. So it has a ratio of 0.1, 0.8 and 0.2. This is one way of giving the color for the given graph. right? Are able to understand? This is of plot 2D sin x curve. Now let's go to the next one. So this is what the another. See, the another way of giving color is I can give it as 1 minute. I can give it as color equal to blue. Color equal to blue. This is another way of giving the color for the graph. I can, instead of RGB color, I can give it as here also. Let's change it here. Here I'm going to plot cos x, cos of x from the in the range minus 2 pi to plus 2 pi, and my line style will be double hyphen color equal to blue, show P1. So if I just run it, right? If I just run it this, see that I'm getting a blue color curve, cos x curve, blue color with a dashed line, double dash, hyphen. Are able to understand? Right? This is what the plot command is. So there exists two ways of giving the color. Either I can give it as RGB, red, green, blue ratio, or I can give it as color equal to blue. Right? This is two ways of giving the thing. Now, if I want to draw many curves in the same graph, that is, I want to superimpose the thing, right? For that, what I have to do is, I'm going to have first P1 equal to plot of sin x. I'm going to plot the sin x in the range minus 2 pi to plus 2 pi with the thickness 2. The RGB color, see the RGB color here, red is predominant. Red and blue are predominant, 0.7 and 0.6. And my legend label equal to sin x. Now I'm going to have another plot, P2 equal to plot of cos x minus 2 pi to plus 2 pi. The range is same. The thickness is little bit more thickness than the previous one. And in RGB color, I gave green as a predominant color, right? 0.8 RGB color and legend label as cos x. Now I'm going to have another plot P3, plot of x square. I'm going to plot x square curve from the same, what you call, range minus 2 pi to plus 2 pi, and my color equal to brown. This plot will be a brown. So what I'm going to do is, if I want to have these three curves in the same graph, what I should do is, first I have to draw P1, then plus. What it will do is, in the same graph, it will superimpose the second graph P2, right? Then this plus will again superimpose the another graph P3. Are able to understand? Now P4 dot axis underscore labels are x comma f of x. So it will actually term the x axis as x and y axis as f of x. Show P4. Now if I select this, right, and run it, so I will get all the three graphs in the same graph. It will superimpose and give you y equal to x square. It is there, right? Sin x curve, cos x curve. Are able to understand? So I can superimpose many graphs in the same thing. Are able to understand? I can have another thing, P4 also. P4 also I can have. If I have P4, then I have to change this P5 equal to P1 plus P2 plus P3 plus P4. So what it will do is, it will superimpose all the four graphs in the same graph. Are able to understand? So to superimpose or to draw the many graphs in the same graph, many curves in the same graph, I have to use summation symbol, plus plus P1 plus P2 plus P3 plus P4, etc. Right? Superimposing the things. Are you able to understand? So in MATLAB, what you will do is you will put it as hold on, hold off, right? But here it is very easy. You have to just add it, right? Whatever you are doing in MATLAB, the mathematical terms, most of the thing you can do it in Sage, right? But the engineering thing, MATLAB is very, very important for engineering toolboxes, right? Now we are going to have another thing. Now here I'm going to initialize the variable
Dhanasekar,
x.
sir?
Yes.
1 minute, sir. Ask the participants they are got the output or not.
Okay.
parallelly, I am pasting that chat box and your question and answer sessions also, so that you can either copy from chat box or in the question and answer section also. Which one is up to you? You may copy from there. Dushyant Gaikwad sir, what is the issue from your side? Are you copied fully or are you typed? You may get the code from your question and answer session also. Dushyant sir. Okay, Dhanashekhar sir, you can go on, sir. Then I will
Thank you.
take care, sir.
Okay, now we are going to actually I actually initialize a variable x. Now I'm going to plot the sin x curve in the range. The range can, because why I'm giving it as x's, I'm going to fill that thing, right? I gave it as a variable x. Therefore, the range is given as x from 0 to 2 pi, fill equal to true. Now, if I run it, if I run this thing, right, copy and run it, see that the thing sin x curve is filled up with some gray color. Okay, gray color will be filled up. So this can be useful when you are finding out the area. So you can tell the students that this area is, we are actually finding it out. Are you able to understand? This area we are going to finding it out. Are you able to understand? Right? Now, the next thing we are going to do is, we are going to draw, right, many graphs in the single window. That means you are going to divide the window, right? You are going to divide the window into 4 or 6, and you are going to draw each and everything, as a 6 graphs. You are going to have it in a single window. That's what we are going to do. This is a Python code, and we are getting the help of Python and doing it. We have a Sage code also. Now import matplotlib.pyplot as PLT. So you are going to import the matplot library. From that matplot library, you are going to import pyplot, that is Python plot, as PLT. And you are going to import numerical Python as NP. And you are going to give the X range. My X range is np.arrange, that is from 0 to 10 with the increment of 0.1. So I'm going to take the point as 0, 0.1, 0.2, etc. up to 10. Are you able to understand? Now, fix comma ax equal to plt.subplots. You are going to divide the window into 2, 3. That is 2 rows and 3 columns. You are going to divide the window into 2 rows and 3 columns, right? And also please remember that in Sage, if I'm writing a matrix, right? Or usually the first position of the matrix will be denoted by 1, 1. But in Sage, always the numbers will start from 0. For example, if I say that the numbers are from the numbers which are less than or equal to 9, it will start from 0 and it will take. Similarly, the first row in Sage, it will take it as 0. First row is 0 row. Are you able to understand? For example, if I have a 2 by 2 matrix, the first position usually we will denote it as 1, 1. But in Sage, it will be denoted as 0, 0. 0 row and 0 column, first one. Are you able to understand? That's why here ax of 0, 0. This is nothing but first position. So your window will be divided into 2 rows and 3 columns. So you will have 6 graphs will be there. So ax of 0, 0 dot plot. In this one, you are going to plot y equal to x line. Y equal to x line. We are going to plot it for x. So it will take the points of this x and substitute in y equal to x, and it will draw the things. Are you able to understand? Ax of 0, 1 dot plot x, x square. You are going to plot it in the second one. That is second position. 0, 1. First row, second column. Are you able to understand? First row, third column, you are going to plot sin x curve. Right? Then 1, 0 is nothing but second row, first column. You are going to plot square root of x. This np dot, why we are using it? It is not necessary, right? Because we have We use the np.arrange here. Therefore, we are taking np.square root, right? So np.square root of x, then the second row, right, second column, you are going to plot 1 by x curve. Then second row, third column, you are going to plot cos x curve. Now we are going to ask plt.show, and you are going to save this figure as demo1.png. This will be showed in your downloads. This will be stored in your pictures or in your downloads. It will be there in your computer. As a demo.png. Save figure demo.png. Now if I run this code, right? Run this code. See that I'm getting 6 figures. So your window is divided into 2 rows, 3 columns. This is 0, 0, 0, 1, 0, 2, right? 1, 0, 1, 1, 1, 2. Are you able to understand the position? First, you are putting y equal to x. Next, y equal to x square. Next one is sin x. Then this is square root of x. I think this is 1 by x. This is cos x. That's what I'm thinking, right? This is what you are getting. So when I want to have this kind of thing, right, I can make use of this Python code. This is a Python code, right? First, you are going to tell subplots, how many subplots you are going to. That is, first you have to instruct the Sage that you are going to divide the windows into 2 rows and 3 columns. If I want to have only 4 graphs, then I can put it as 2, 2. But you have to put it here carefully. It's not 1, 1. It is 0, 0. It starts from 0. Right? Now let's go to the next one. Right? This is the Sage way of doing the things. Now I'm going to plot 4 graphs in the same window. Right? Plot f of x. I'm going to take f of x as sin x, g of x as sin 2x, h of x as sin 4x. Are you able to understand? My plot P1 is nothing but plot of f sin x from the range minus 2 pi to plus 2 pi, color who equal to 0.5. According to this ratio who 0.5, right, the color will be displayed. That it's a combination of more colors, right? It is a combination of colors. Now P2 equal to plot g comma minus, it is the same range minus 2 pi to plus 2 pi, color equal to hue 0.9. Now P3 equal to parametric plot. This I will tell you what is parametric plot. Now you just listen. Parametric underscore plot. You are going to take sin x and sin 2x. Then the range is from 0 to 2 pi. Color is hue 0.6. Now P4 is parametric underscore plot. F comma h. Right? 0 comma 2 star pi. The range is color is hue 1.0. Now I got 4 plots. Now this graphics underscore array. This graphics underscore array. What it is telling, it will make it this as first row, P1 comma P2, and P3 comma P4 as second row. Are you able to understand? Now if I run this code, if I run it, now see that I'm getting 4 graphs. Now I'm getting 4 graphs. According to the hue 0.5, 0.6 and 0.9, the color or varies. Are you able to understand? Color varies. These two are parametric plots. Am I right? Parametric plot, parametric underscore plot. This is another way of doing the things. So this is the Sage way, graphics underscore array. Graphics underscore array. Are you able to understand? Right? Now let's go to the parametric plot. What is parametric plot? Right? Now here we are going to do the parametric plot. Right? 1 minute. I will take this out. Right? Variation of t. Right? Now f. And I'm going to take g. I'm going to take parametric plot. Right? Now here, what is this? This is nothing but, right, at square to 80. 80 square to 80. What is the parametric form of parabola? 80 square and 280. Are you able to understand? So we are going to plot the parabola by using parametric underscore plot. So I'm going to just take this as a comment. Now I'm going to run it, right? This also comment. Now I'm going to run it. Variable of t, I'm going to plot the parabola. First, I will plot the parabola. Then if you know any parametric form of any graph, you can do it.
So, Dhanasekar sir,
Yes.
your code and my codes are somehow different, sir. The function only will be different.
That's I will change it. It will be in cos. I think it will be for circle.
Okay, sir. Then I will modify, sir. You can explain.
No problem. I will tell now. Right? Thank you. Now see that I will get a parabola here. So parametric plot. If you know the parametric form, you can do the things. Now, for example, if I have a what do you call a thing, right? Now, if I take this as 4-star cos of t, cos of t. So it is r cos theta, and I'm going to take r sin theta. 4-star, okay, sine of t. So it is r cos theta, r sin theta. Now I'm going to do the thing, parametric plot. Now if I run it, it's running. See that I'm getting a circle. Are you able to understand? So according to your parametric form, you will get it. Now what is the parametric form of ellipse? It is a cos t and a b sin t. Let's take b as 9. Okay. So now I'm going to plot the ellipse. Right? Now if I run it, see that I'm getting an ellipse. Are you able to understand? As a major axis 4 and minor axis 6. Right? So parametric plot will help you to, if you know the parametric form of anything, you can do it by using the parametric underscore plot. Parametric underscore plot. Are you able to understand? Right? Okay. Now we are going to plot the equation of tangent. Equation of tangent, right? We are going to plot equation of tangent, right? Now, what is the equation of tangent? Equation of tangent is y minus y1 or y0, right? Y minus y0 equal to m into x minus x0. This is what the thing is all about, right? That means my y equal to y0 plus m into x minus x0. What is m? M is slope. Slope is nothing but dy by dx at the point x0 comma y0 or at x0. Am I right? That's what your m is. Now, first, I'm actually declaring the variable or initializing the variable. X is equal to variance of x, and I'm actually fixing the point. My x0 is 1. I'm going to find equation of tangent at the point 1. x0 is 1. X is 1. Now the curve is f of x equal to x cube. That's a curve I'm going to take, x cube. So I'm going to find the equation of tangent for the curve x cube at the point 1. X point is 1. Right? Now P1 equal to plot. First, what are all the 3 things I have to do to get the equation of tangent visualization part? First, I need to draw the curve. Second, I need to draw the point. Then I have to draw the tangent. So 3 things should be there in the single graph. Then what is the command? We know that the command is summation. P1 plus P2 plus P3. Am I right? That's the thing. Therefore, first I'm taking P1. P1 equal to plot f of x. So it will plot the curve, this x cube curve. The range, x range is minus pi to plus pi. Minus pi to plus pi. Then I have to find out my m value. How my m value will be? My m is nothing but slope. For that, first I have to find out differentiation of f of x. So the differentiation command in Sage is diff, di-double-f. Right? This will be handled by Manivan and tomorrow elaborately, calculus part. So d f of x I'm going to take diff, di-double-f, diff of f of x comma x. So this will differentiate the given function x with respect to x, f of x with respect to x. Now I want to substitute this x naught in this this differentiation part so that it will become m. Therefore, m equal to df of, in the place of x naught, you are replacing it by x naught. So this will give me my m slope, m equal to df of x naught, m df of x naught. Right? Then I'm going to plot the tangent line, P2 equal to plot y naught. What is y naught? Y naught is nothing but f of x naught plus m. M is slope star x minus x naught, where your x ranges from minus pi to plus pi, and you are going to give the color as green. So your tangent line will be of green. Are you able to understand? Now I'm going to plot the point P3 equal to list underscore plot. This will plot the point. What point you are going to plot is x naught comma y naught. That is x naught comma f of x naught. What will be your size? Your size equal to 30, color equal to red. Therefore, the point will be in red. Now, all the three things will be in the same figure. Now, here I called upon m. I called upon the differentiation part. I called the equation of tangent, right? All the things. Now, if I select this, right, and run it, see that I'm getting y equal to x cube curve and the tangent on the point x naught point, and it is giving m value is giving, the differentiation is giving. Are you able to understand? Right? This is how you have to do the programming in Sage. If you understand the basic thing, then you can go on for programming for your course. Are you able to understand? Right? Now let's come to the plotting the vector field. Now when we are doing the vector part, right? So for us to visualize the vector, right, it is a little bit difficult for us. Now we are going to do that, right? Now first I'm going to actually initialize the variable y, and I'm going to visualize the vector minus yi vector plus xj vector. We are going to see only two-dimensional vector field. Now I'm going to visualize minus yi vector plus xj vector. That's what I'm going to do. So plot underscore vector underscore field. That's a command for vector field. Y equal to variable y, plot underscore vector underscore field minus y comma x, where x is from minus 2 to plus 2 and y is from minus 2 to plus 2. So now if I run this, I'm getting a vector field. See that visualization of the vector field is here, right? So it will change the direction of x as negative with the magnitude of y. That's why it does look like that. It's look like it's a rotational vector field. Rotational vector field. Am I right? So this is the way. Manivanan, is this code is there? Is there many variations are there? Manivanan?
Sir, functions only maybe vary, sir. I just little bit modified, sir. No issue.
Okay. Sorry for it, Manivanan. Okay.
No, sir. No, sir. No problem.
Okay. So this is what your plot vector field is. This is, you are going to plot the two-dimensional vector field. Right? Now let's go to the next one. Plotting vector field of gradient. Gradient. You are going to plot the gradient field. Now what is gradient operator? Gradient operator is, if you give a scalar, it will give back as a vector. That is, if f is given, it will be given, right, f vector like dou f by dou x into I vector plus dou f by dou y into j vector plus dou f by dou z into k vector. Am I right? Therefore, first I'm initializing the variable. Next, I'm going to give the scalar function x square plus 2 star y square. And I'm going to put plot underscore vector underscore field. Now, instead of this f, I'm going to put f dot gradient. So this f dot gradient will help us to find out the gradient of this scalar function. gradient of the scalar function. Now you are going to plot it with the range x from -2 to +2, y from -2 to +2. And to make it as little bit catchy, you are giving grid lines equal to minor. This grid lines equal to minor. Are you able to understand? Now, if we want to see the what is gradient function is, you can assign as q and call it as q. Now, if I run this, see that I'm getting the gradient field. So I'm getting a gradient value 2x and 4y as an ordered pair. See that grid lines are there, smaller grid lines, to make it as little bit catchy, right? Are you able to understand? So for visualizing gradient, the command is same, vector field command, but only thing is instead of f, you have to put f dot gradient, right? Now let's go to the contour plot. Let's go to the plot 3D. Now we are going to do the plot 3D. Now variance of xy, you are initializing the variable, and your function f is equal to x square plus y square, and you are going to plot 3D. You are going to plot this 3-dimensional curve, right? Using color equal to green, right? Now if I show A, so to plot the 3-dimensional curve, the command is plot 3D. Now if I run it, now see that 3D is seen as loading actually. You will get that surface figure, right? You can rotate it. It's a 3D figure. You can rotate it. It's a convex function, all right? It's like a bowl, convex function. It's like a bowl. Are you able to understand? I can rotate it and I can see the coordinates. Now to have a plot 3D, right? Plot 3-dimension figure, I need to put plot 3D. Are you able to understand? Now we come to the contour plot. You know about what is contour. Contour is nothing but projection of level curves. Am I right? Projection of level curves in the XY plane. So where the contours are important is, level curves are very important is, when I want to find out maximum and minimum, this contours has a very vital role, right? I need to, for example, if it is a convex function, bowl function, if I have a contour plot, right, I have to reach the minimum point, right? That means if I put it in the XY plane, I have to reach the, if it is a round, I have to reach the center of all the concentric circles. So when you are going for finding maximum and minimum, this contour plot has a very vital role. Contour plots are nothing but projection of your level curves into a 2-dimensional XY plane. What is level curves? Level curves is nothing but if you are having a mountain, then if you're joining those points which are in the same height, that curve is called level curve of that height. What it means that if I go along that curve, that height is not varying. The height will not vary. It will have the same height. That means the contour plots are nothing but throughout that curve, the function value will be same. The function value will be the same. Are you able to understand? Now, I'm going to plot contour plot of x square plus y square. What is x square plus y square? It's nothing but a circle equation with center at origin. You are going to vary the radius and you are going to find it out. Right? The command for contour plot is contour underscore plot. Contour underscore plot. Right? The range is given from -pi to +pi. Y range is given from -pi to +pi. Fill equal to false. If you put fill equal to true, right, more colors will be inside the curve, each and every curve. C map equal to Z. Yesterday, I think Parthiban sir told about color map, right? Then labels equal to true. This labels equal to true will give you the the value of that contour thing, function value at that contour. Now if I select it and run it, see that I'm getting a contour curve, concentric circles with the curve values are given. Are you able to understand? Curve values are given. See that what is this curve has a radius of 2.5 r square, right? R is 2.5. This is the function value at this thing. Are you able to understand? The contour map, right? The contour maps with the gradient vector field visualization as a very vital part in determining. By seeing the contour plot with the gradient, we can say that whether it's a plane or line or like that. We can talk about the plane, the characteristics of the plane. Now we are going to visualize the 3D plot. Now 3D plot visualization can be done by, for this vector, xi vector plus yj vector plus zk vector. Now first I'm initializing the variable yz, plot underscore vector underscore field. Same thing, only thing is you have to add 3D. You have to add 3D. Are you able to understand? You have to give the x range -1 to +1, y range from -1 to +1, z range from -1 to +1. Now if I run this command, right? Run this command. See that I'm getting a 3D plot, loading 3D scene. See that I'm getting a 3D plot. I can rotate it. I can rotate it. 1 minute, I will show it. So I can rotate it. Are you able to understand? This is a 3D vector field. Okay. Now similarly, I can visualize the surface of revolution. For example, when you have a curve, I'm going to visualize the square root of x, and I'm going to rotate that square root of x, revolve around the x-axis. Then what kind of surface you will get it? Are you able to understand? That's what here I'm going to do, or we are going to do. U equal to variance of u, and you are going to declare the curve square root of u. Surf1 equal to revolution underscore plot 3D. So it will give you the 3-dimension figure when you are rotating the CF in the range 0 to 2 parallel to x-axis. You are going to revolve around x-axis. Show curve equal to true. It will show the curve also. The root x curve. Opacity equal to 0.7. This opacity is nothing but the transparent of this frame. Transparent of this frame, right? Surf1 equal to show aspect ratio 1,1. This will give you the, what do you call, this will give you the correct ratio of the axis x, y, z, right? Now if I run it, I will get a curve like this. If I rotate it, see that the curve is given in red color. This is your y equal to root x curve. This y equal to root x curve, when you revolve around x-axis, you are getting a surface like this. Are you able to understand? Surface of revolution. When you are doing a single integral, right, I can visualize this. This is the curve. This curve is rotated, revolved around x-axis to get this surface. Are you able to understand? Okay. Now let's go to the implicit plot. I can have an implicit plot also. I can have an implicit plot also. So implicit underscore plot 3D equal to, you are going to draw this one, x square plus y square plus z square is double equal to 9. What is this equation? This equation is nothing but sphere equation. Am I right? Sphere equation with center at origin with radius 3. Am I right? X square plus y square plus z square equal to rho square, where your x varies from -4 to +4, y varies from -4 to +4. These are all the range. Z varies from -4 to +4. Now if I run it, run it, See that I will get a sphere. It's loading. Wait for it. See that I'm getting a sphere inside a frame mode. All the 3D figures in Sage will be inside a frame. If you don't want this frame, you have to give frame equal to false in the plot 3D. Are you able to understand? If I give false equal to, that is frame equal to false, this frame will not come, only the sphere will come. Are you able to understand? Most of all the 3D figures in the Sage will be in the frame itself, inside a frame. Now let's go to the next one, right? Now we can superimpose 2D figures. Now I can impose 3D figures also superimpose. For example, I want to superimpose this curve sine. 1 minute. I want to superimpose two 3D figures. One is sphere with radius with origin 0, 0, right sphere, right? And I'm going to combine this two, sine of pi into x square plus y square by 2. So this 3D curve and this 3D surface, I'm going to both have it in the same graph. That is, I'm going to superimpose it. So this can be done by using the same command called plus. First, your plot 3D. You are going to plot the 3-dimensional plot sine pi into x square plus y square by 2 with the range x minus 1 to plus 1, y range from minus 1 to plus 1. I don't want the frame. Therefore, I'm putting frame equal to false. Color equal to purple. This plot 3D will be of purple color with opacity. What I do know that opacity is, if the frame is not also there, right? Okay, invisibly the frame will be there. Therefore, this opacity should be there, 0.8. Now, next I'm going to draw the sphere. Sphere with center at origin with size 0.3, color equal to red. Sphere will be in red. Whenever you are going for circle, sphere, ellipse and all that, if you give the aspect ratio, then only it will be intact in the axis. Now show W plus S. Now if I run it this, see that I'm getting that plot pi x square plus y square. Inside that the sphere is there. Sphere is red and this is the thing. Now I put it as frame equal to false. That's why the frame is not coming here. 3 dimension. This is the curve. Purple curve is pi into x square plus y square by 2, and this is the sphere. Red is sphere. Are you able to understand? Therefore, superimposition can be done in 3 dimension also in Sage. That's a huge advantage of drawing the figures. Right? Okay. Now I can draw the piecewise curve also. The command is piecewise. Piecewise, you are going to have from 0 to 1, the function value is -1. From 1 to 2, the function value is 1. Are you able to understand? You are going to draw this piecewise piecewise curve. So piecewise, first you have to give see that the syntax, first open bracket, next close the bracket, then again open bracket, then the 0, 1. The range is given. In that range, the function value is -1. Next, the range is given 1 to 2. In that, the range value is 1. So the function value is 1. Plot f inside the range 0, 2. Now, if I run this, I'm selecting and run it. If I'm selecting and run it, now see that I can draw the piecewise continuous curve. See that from 0 to 1 it is -1. From 1 to 2 it is 1. Are you able to understand? You can draw the piecewise curve also. When you are doing Fourier series, Laplace, it will be useful for you. Are you able to understand? So I hope I can cover most of the plotting things, right? I hope I have time. Am I right, ma'am?
Dhanasekar sir,
Yes.
already time near over, sir. Maybe the question and answer, sir. If you are giving, then that's fine, sir.
Okay. 1 minute, I will
Sir,
come out of.
you have something to complete, sir, or you're done with it?
No. I have matrices with me, right? But it will take another 15 to 20 minutes.
Shall we continue for tomorrow's session, sir? If that's the case.
That no problem. Manivanan will take it. Otherwise, I will take it tomorrow also. No problem for 15 minutes.
Okay. Yeah.
Then Manivanan will come. And
Yeah.
Okay, ma'am. I will stop sharing my thing.
Okay. Sir, thank you so much. Sir, I think earlier we had that problem of not copying things and things like that. And later on, I think they got the solution of putting them in the Q&A mode, and then they were able to copy it. Thank you so much, sir, for joining us and accepting our invitation and giving your session, sir. That was very informative. And even in the YouTube, I was able to see that there were so many positive feedbacks coming out from your sessions. So thank you so much, sir. And going back to the Q&A, we'll just see one or two questions. So a question has been asked, how to modify code to find the exact generator of curve, to calculate the exact generator of curve.
I can't understand. Satyaraj Govindan, sir, you can just elaborate what you mean. What is meant by generator of curve?
Yeah, what is meant by a generator of a curve?
Aziz Ahmad, we will give the code to the organizers. They will already they send it, right?
Yeah. After the session, we can share it, sir.
Yes, so that you can see the YouTube live
And Dhanasekar sir, and if it is possible, you can tell sir they can download their Sage code from their Sage file itself.
Yeah. You can
GoCal
download
itself,
it from
you can download.
If you have a GoCal thing, you can download it from there, and it will be there always. Whenever you open, it will be there.
And the left side, that down mark you go, sir. Left side, below that, sir. Nearby run button, that left side one. Left. Yes, sir. You just put it, sir. And download option is there. Download option is there, so that you can download. And in mode also, you can made me suppose PDF file if you want it, you can download the PDF.
It's downloaded actually.
So it's in the cloud. So anytime you can access, and moreover you can download the PDF format also.
So it will ask you how to open it. You can give notepad or whatever you want. You can give it so that it will open. Okay.
So I think those many questions only, sir. Shall we wind up the session, sir? Thank you, sir, once again.
Yes, ma'am. Yes,
on behalf of Kumuruguru institutions, sir, thank you so much from VIT. You have come all the way, and you have spent your time in instilling the great, our minds with all these technical ideas with respect to the SageMath. And I think all the participants and as well as me, we all had a very useful session, and we enjoyed the process of learning along with you. And it was also a pleasure to have all three of you as panelists, and you were very comfortable with all three of you. Made it sure that all the participants listen to your session. So that was very interesting. And this SageMath with respect to calculus and the other applications was very informative, because whenever we look into the vector fields, that is separate. When we look into the 2D or 3D plots, it was separate. But you were able to so very well merge together all these ideas. So that was very great from your side, sir. And we thoroughly enjoyed the session. I believe the participants also must have got a very good insight about the SageMath kind of thing. And the same SageMath will be continuing for tomorrow's session as well. So expecting participants to continue and to join us for tomorrow's session at the same time. And so that's it from our side. I request all the participants to kindly fill up the feedback form before you log out the sessions. And thank you once again. Sir, I thank all three of you from VIT to join us and to be along with us for the next 3 days. Thank you so much, sir. once again, this is Maheshwari signing off from Kumuruguru Institutions. Thank you all. Thank you.
Thank you very much, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, Manivanan. Thank you.
Anything that you would say from your side, sir, that you would like to share from your side?
No, I already told that, no, it's a very good initiative done by you. Right, keep it up, and in further future endeavor, anything you want from VIT Chennai, we are ready to do it.
Okay, sir. Thank you so much, sir. Yes, even we are hoping to coordinate with you in our near future, sir.
Definitely,
so we'll have many more sessions of this kind. Thank you, sir.
Yes, ma'am. Thank you very much. Thank you, Mani.
Okay.
Thank you, Parthiban.
Thank you, ma'am. Thank you. Thank you,
Thank you.
Thank you.
Dhanasekar,
Thank
sir.
you, Manivanan, sir, and Parthiban, sir. Thank you so much.
Thank you to all. Bye.
Thank you.